Nonmetals are a diverse group of chemical elements that exhibit a wide range of physical and chemical properties. Unlike metals, nonmetals are generally poor conductors of heat and electricity, and they tend to have low melting and boiling points. They also lack the metallic luster and malleability of metals, and are often brittle in their solid form. Nonmetals can be found in all three states of matter: solid, liquid, and gas, at room temperature, and many of them are essential building blocks of life. The most abundant nonmetal in the Earth's crust is oxygen, which makes up approximately 46% of its mass, followed by silicon, which makes up around 28%. Other important nonmetals include nitrogen, carbon, hydrogen, sulfur, chlorine, fluorine, and bromine. Nonmetals play critical roles in many aspects of modern life. For example, nitrogen and oxygen are used in the production of fertilizers, while carbon is a key component of many materials, including plastics and graphite. Chlorine and fluorine are used in the production of a wide range of products, from pharmaceuticals to refrigerants, while hydrogen is used as a fuel in hydrogen fuel cells. Nonmetals also play important roles in the natural world. Oxygen is essential for respiration in living organisms, while carbon is the basis of all known life on Earth. Nitrogen is a critical component of DNA and proteins, and sulfur is important for the formation of proteins and enzymes. Overall, nonmetals are a diverse and essential group of elements that play a vital role in both human life and the natural world. Nonmetals can be classified into several groups based on their chemical properties and their position in the periodic table. The main groups are reactive nonmetals. These nonmetals are highly reactive and tend to form covalent bonds with other elements. They include hydrogen, fluorine, chlorine, bromine, and iodine. Noble gases. These nonmetals are inert and do not form chemical bonds with other elements. They include helium, neon, argon, krypton, xenon, and radon. Metalloids. These elements have properties that are intermediate between metals and nonmetals. They include boron, silicon, germanium, arsenic, antimony, and tellurium. The study of nonmetals involves understanding their physical and chemical properties, as well as their uses in various applications. Some of the key properties of nonmetals include electronegativity. Nonmetals have a high electronegativity, which means they have a strong attraction for electrons. Ionization energy. Nonmetals have a high ionization energy, which means it requires a lot of energy to remove an electron from their outer shell. Electron affinity. Nonmetals have a high electron affinity, which means they have a strong attraction for additional electrons. Reactivity. Nonmetals can be highly reactive, especially with metals, and can form a wide range of compounds. In terms of their applications, nonmetals are used in a variety of industries, including agriculture, healthcare, electronics, and manufacturing. For example, nitrogen is used in fertilizers, oxygen is used in medical applications, and chlorine is used in the production of plastics and other materials. Carbon is also a key component in a variety of applications, including batteries, steel production, and electronics. Understanding the properties and applications of nonmetals is therefore critical for a wide range of industries and scientific fields. Nonmetals have several characteristics and properties that distinguish them from metals. Some of the key characteristics and properties of nonmetals are: poor electrical conductivity. Nonmetals are generally poor conductors of electricity. This is because they do not have free electrons that can move easily through the material to carry an electrical charge. Brittle and non-malleable. Nonmetals are typically brittle and non-malleable. This means that they are not easily shaped or molded into different forms. Low melting and boiling points. Nonmetals typically have low melting and boiling points, which means they can be easily melted or boiled at low temperatures. Non-reflective. Nonmetals lack the metallic cluster of metals and are typically non-reflective. High electronegativity. Nonmetals have a high electronegativity, which means they have a strong attraction for electrons. Tendency to form covalent bonds. Nonmetals have a tendency to form covalent bonds with other nonmetals. Covalent bonds involve the sharing of electrons between atoms, rather than the transfer of electrons from one atom to another. Tendency to gain electrons. Nonmetals have a tendency to gain electrons in chemical reactions, which results in the formation of negatively charged ions. High ionization energy. Nonmetals have a high ionization energy, which means that it requires a lot of energy to remove an electron from their outer shell. Tendency to form acidic oxides. Nonmetals tend to form acidic oxides when they react with oxygen. This is because the resulting oxides can form acidic solutions when they dissolve in water. Variable oxidation states. Nonmetals can have a range of oxidation states, which means they can gain or lose different numbers of electrons depending on the chemical reaction. Overall, nonmetals have a diverse range of characteristics and properties that make them essential in many different applications, from fertilizers and pharmaceuticals to electronics and manufacturing. Understanding the unique properties of nonmetals is therefore critical for many different scientific and industrial fields. Nonmetals are located on the right side of the periodic table, in the p block elements. The p block elements are the elements in groups 13 through 18, excluding helium, which includes nonmetals, metalloids, and some metals. Specifically, nonmetals are located in groups 14, 15, 16, and 17 of the periodic table. Group 14 includes the nonmetal carbon and the metalloid silicon, while group 15 includes the nonmetals nitrogen, phosphorus, arsenic, antimony, and bismuth. Group 16 includes the nonmetals oxygen, sulfur, selenium, tellurium, and polonium, while group 17 includes the nonmetals fluorine, chlorine, bromine, iodine, and astatine. The nonmetals can be further divided into two main groups based on their reactivity, the noble gases and the reactive nonmetals. The noble gases, helium, neon, argon, krypton, xenon, and radon, are completely inert and do not typically form chemical bonds with other elements. The reactive nonmetals, on the other hand, are highly reactive and tend to form covalent bonds with other elements. Understanding the position and grouping of nonmetals in the periodic table is important for predicting their properties and behaviors, as well as for identifying potential applications in various industries and scientific fields.